Alright guys, the topic for now is your Flex VPN. Flex VPN is a type of VPN that consolidates different type of VPNs into one. If you see what we have done in the past, we've gone from a site-to-site VPN, which is a certain type of setup, certain type of commands. We've gone to a spoke-to-spoke type of VPN, which is like your DN VPN, where spokes can talk to each other directly, okay, through the hub, which is your DN VPN, which is a completely different type of setup. And then we took a look at Easy VPN, which again, the setup is completely different. It's for remote access. What Cisco has done with Flex VPN is try to consolidate the commands, the setup of all these three types of VPNs, whether it's site-to-site, whether it's spoke-to-spoke, which is DMVPN, or Easy VPN, which is server client, into one type of setup called the Flex VPN. So Flex VPN is a different command set that allows you the ability to get all those three type of VPNs that you could do in your normal setup using completely different type of setups under one umbrella, under one command set. You'll see there's a lot of similarities in terms of how you do Flex VPN, how do you do site-to-site, spoke-to-spoke, or server client. They all fall under the same type of command set. You'll see a lot of similarities over there. Do you understand what Flex VPN is? Flex VPN gives you the capability of doing all these three type of VPNs under one umbrella, one type of command set. One of the requirements of doing Flex VPN is that it requires IKV2. You need to understand there's a difference between IKV2 and Flex. What we did yesterday was IKV2. What I'm going to do today is Flex VPN, but Flex VPN, in order to run it, phase 1 needs to be IKV2. Make sense? You guys are okay with that?
Yeah.
So it is dependent on IKV2. So if I'm running IKV2, I need to have the appropriate iOS for that. I'm going to do this on the 15.x code. Okay? What I'm going to do is I'm going to do it one at a time. We're going to start with the site-to-site, which is lab 1 of module 5. Site-to-site VPN using Flex VPN. Then we'll take a look at spoke-to-spoke, and then we'll take a look at server client. Lab 2 and lab 3. Good to go? Let's take a look. First things, let's set the topology up. Again, I'll need a 7200 over here. I'll do it between 1 and 2, and I'll put the 3700 in the middle as the internet router. While it's coming up, actually it's 13, right? Takes the other guy to some time to come up, so in the meantime I'll copy, configure the other site as well. 23.2. Copy it. 23.2. Very good. So the devices are communicating to each other. Now, let's say I want to do flex VPN site to site. I want to connect site 1 to site 2. How do I go about doing it? Let's take a look. The first thing that I need to do is create, and you'll understand that later on. I'm going to set up the server end, the hub end, or one of the ends, as a static end, the other one static IP. The other one can be static. If I do static, is what I did yesterday. Remember SVTI with IKE v2? But there's sometimes what happens is I do want to do static on one side. I want to do VTI. On the other side, I have a dynamic IP. You have two sites. One site is getting an IP address assigned to them by the ISP. The other one has a static IP. So in that case, I cannot do a pure SVTI. I cannot do a pure SVTI on both sides because the tunnel destination cannot be specified, because that one has the second site has what? A dynamic IP. So what I do in that case is on the server end, on the one that has a static IP, I'll create a DVTI interface and allow the other client, when it comes up, it points towards what? The static site, and start setting up a VTI tunnel where I need to have a dynamic VTI, the virtual template, ready to receive that address. You understand where I'm trying to get to? So one side I'll have a static VTI where tunnel destination will be specified. The other one, because I cannot specify a destination in the virtual template. Now when I set the virtual template up, I cannot set an IP address on the virtual template itself. I need to gather the IP address from another interface. So the first thing that I will need to do on this guy is I'm going to create a loopback. Loopback, let's say 10. This loopback will have the same address that I want on the VTI tunnel. Remember when we set up the SVTI, I said the tunnel IP is 192.168.1.0. He will set it manually, but I cannot set it on the virtual template. So what I'll do is I will set it up on what? On a loopback. Okay. Go to my virtual template, one type tunnel, and call it. Do you understand what I did? The way I'm going to set the IP address of that virtual interface is by calling it from the loopback. I cannot manually set an IP address on a virtual template. Then I'll specify my tunnel source. Let's say S1/0. Tunnel destination I don't know because the other guy might have a dynamic IP. But at least I can set the tunnel mode to what? IPsec, IPv4. The last command that I need to set up on the virtual template was the tunnel protection. I don't have that yet. What tunnel protection? The profile. We'll set that. Give me a second. We'll come back into what? Tunnel 1, virtual template 1, and set that tunnel protection, the IPsec profile. So what steps did I do so far? Let's take a look at them. Step 1, configure the virtual template. Right? How did I do it? Interface loopback, let's say 10. IP address 192.168.1.1. Good. Interface. Why did I set that loopback? Because I cannot manually set the IP address over there. IP unnumbered. Tunnel source. Tunnel mode. And that's about it for right now. Good. Step 2. And I'm going to combine this over here. Step 2. Configure IKE v2. Do you guys remember the 4 steps for IKE v2? All 4 steps I'm going to put into this. What steps? Crypto, IKE v2 proposal, integrity, say MD5, group 2, encryption. Good. What else? Crypto, Ike v2, policy, pol1, proposal, prop1. Crypto, Ike v2, keyring, kr_1, peer r2, address, pre-shared key, we'll set up a single one. Crypto, Ike v2, profile, prof_1, match address, match identity, remote address 23.2, authentication local, and remote. Key ring, local. Last thing, which I normally did not do in the previous example, what do? Attach my virtual template to it. What that means is when this guy comes in, 23.2, he will be assigned a interface, a virtual tunnel interface based on the template. So when he logs in, he gets authenticated. He will be assigned a separate interface based on what? The template interface. Good? These are the 4 steps, the normal 4 steps for what? Ike version 2. Good? The next thing, step 3. Configure IPsec profile, crypto IPsec profile, ABC, transform set, step 4, configure an IPsec profile. What do I do inside it? Set my transform set and set Ike v2 profile, just like I did for that SVTI with Ike v2. Taken care of. Now I need to go back, assign the IPsec profile to the virtual template because I want to encrypt it. Interface virtual template 1, tunnel protection, IPsec profile ABC. The reason I could not do it over here, I didn't do it over here, was what? I didn't have that profile at the time. So I needed to create the profile first and then I would do it. So I'm going back to the same interface and saying any traffic going over this virtual template should be encrypted using this. Good? Clear? Last thing, run your routing protocol. This new virtual access interface that you're going to run will be 192.168.1.1 because it's going to gather the IP address from that loopback IPN number. So I'll say router EIGRP 100, no auto, network 192.168.1.0, and advertise my 10 network. Good? It's a lot more than 10 steps, but I combine them because these 4 steps I combine into what? One step. I put Ike v2 as one step. In reality, it's 4. So let's recap. First, configure what? Your virtual template, which requires a loopback, which will be called. Tunnel source, tunnel mode, IP unnumbered. Step 2, configure Ike v2, the normal Ike v2 stuff. Then you go and create your transform set, call it inside a profile, IPsec profile, along with the Ike v2 profile. Assign the profile to the existing virtual template that you created earlier on, run the routing protocol. Why did I need to do it? Because the other side does not have a static IP. He has a dynamic IP. So I cannot set a tunnel destination to it. I cannot do a normal SVTI to it. Copy it. Go to router 1. I had done this already, but that's okay. It's going to override it. Good. Now, what do I do on the other side? R2. R2, I don't need to do this. Why not? R2 can point to him based on what? An IP address. So I don't need to create a virtual template. I'll start doing the same exact thing that I did yesterday for the SVTI. Configure this 13.1. I don't need a virtual template. Step 2, configure a transform set. Step 3, IPsec profile. Step 4, configure your tunnel interface. Here, I'm not doing a virtual template, I'm doing a normal tunnel. What does it have? IP address. Needs to be in the same network as what? The other one. Tunnel source, tunnel mode, tunnel protection. Oh, sorry, one more thing. This one does need a destination because it's static. He needs to point to him. Both cannot be dynamic. If both are dynamic, who finds who? One can be dynamic, the other one will be static. And the last step, run routing protocol. Go to router 2, paste it, tunnel up, EIGRP up. Show IP route. Let's check EIGRP. I've learned 10.1. From where? From 192.168.1.1. Nothing different over here, it's just the normal tunnel interface. Protocol IPsec, and it's encrypted using IPsec. But on the other side, what has happened is a new interface has been added, virtual access 1, which is copied from what? The virtual template. And if you take a look at it, automatically gains the tunnel destination. And it's cloned from virtual template 1. Tunnel protocol is IPsec, encrypted using ABC. And it would also have learned your 10.2. Why does the tunnel come up automatically? Because I ran EIGRP on it. EIGRP sends the hello packet over the tunnel interface. That's your, because it's a routing based VPN, so anything that goes over the tunnel, it needs to be encrypted, so it's sent. Same thing with when we did SVTI. The tunnel automatically comes up because of the routing. If I did not enable routing, it would not come up automatically. Even in this, you need some interesting trigger traffic to bring the tunnel up. The only difference is, here the interesting traffic automatically triggers because of routing. Because I ran routing. If I did not run routing, I was doing static routes, then traffic needs to be initiated. Got it? This is SVTI on one side, DVTI on the other side, overall picture called the Flex VPN site to site. Let's save it.